Here. Today, hopefully you watched my last video on example 3a. I'm going to go ahead and do example 3b and then example 4, but I want you guys to try it out first, and then you can come back and watch. If you do it and you just want to see if it's right, you can obviously check the key or go to the end so you can just see the answers, but try to complete the two problems first. Okay. All right. So with B, it's very similar to A was. I will say, and I'll do this one slightly different than I did for A, just because you could do the exact same work I did for A, get the inverse sign by itself that has the X and then take the sign of both sides, or what you can do, which we will eventually do that, but we can evaluate this first. So inverse cosine of -1, that means I need to use this coordinate point right here, because that's where the x is -1, and that angle that would give me that is pi. So I can evaluate this if my pen decided to start working. Oh. There we go. So I can say inverse cosine of -1 is pi, and then everything on the left side stays the same if it would let me write. Oh, almost. Oh. Okay. There we go. All right, so now it just becomes let's start solving this. So we're trying to get x by itself, so we start from the outside and work our way towards the inside. So I'm going to divide by 3. And now I get pi thirds equals inverse sine of x over 2. And to get rid of inverse sine, you will take the sine of both sides. All right, so this side, those cancel, and you get x over 2. This side, sine of pi over 3, which I'll rewrite that because that's really ugly. Sine of pi over 3, well, that means I draw my pi thirds angle, draw the triangle. If that's pi thirds, we got root 3, 1, and 2. Sorry about that. And sine is opposite over hypotenuse, so it's root 3 over 2. And maybe you know that already now because we've done a lot of these, so if you knew that, you didn't need to draw the triangle. And then our last step to solve for x is to multiply by 2. Nice thing here is 2's all cancel, and you get x equals root 3. Okay, and that right there is your answer for this, yeah. All right, so then again, if you haven't tried example 4, pause the video, go do example 4. This one is actually nice and quick for the most part. So here it tells us we're in standard position, point P is xy, so they tell us that. Then Q, R, and S are reflected over the x and y axis in the origin for each of the following expressions. Okay, so you can write this if you want, right? So that's x comma negative y. This would be negative x comma negative y. This one is negative x comma positive y, right? So there's all those 4 coordinate points. So it's saying here for each of the following expressions, determine which labeled point intersects the terminal ray of the given angle. So you want to look and say, inverse cosine. So inverse cosine, remember if you write out our cosine, inverse cosine has to be in quadrants 1 or 2. So your only 2 options here are P and Q, and we're finding where x is positive, which would mean point P. And that's your answer. Okay. So now let's do the same thing with inverse sine of negative y. So inverse sine, again, quadrants 1 and 4. So my only options are P or S. So now I just need to find, well, the y is negative, which is S. Okay. And if you hadn't tried C and D yet, go ahead and try them. We'll go over those answers real quick. Cool. So back to inverse cosine. Well, that's again, P and Q are your only options. Negative x means that it's point Q. And then last, inverse tangent. Now this one may seem tricky, but if you really think about it, it's not that bad. Because inverse tangent also can only be P or S, right? Quadrants 1 or 4, if you recall. Right, cotan. Oh, it doesn't want me to write. There we go. So we know it's got to be 1 or 2. I'm sorry, 1 or 4. So it's either P or S, and it's negative, which means it can't be P. So it has to be point S. Okay, and that's it. So thanks for watching. Have a good day.